Alright, so the remainder theorem says if you divide a polynomial, like one of these things, um, by a linear factor, x minus some constant, um, then the remainder will be f of that constant. So that's really incredibly handy for evaluating um, the value of a function at a certain value of x. So what the remainder theorem would say is, um, so I want to find what, so f of x is 7x to the fifth plus 3x to the fourth plus 9x to the third plus 2x squared plus 8x plus 11. So kind of a monster polynomial, right? Um, I want to find out what is the value when x is 4. Well, I could plug in 4 for all these x's and say 4 to the fifth times 7 plus 4 to the fourth times 3 plus 4 to the third time, but that would take forever, right? Um, but the remainder theorem says, okay, well, I want to find out the value of f to the fourth. Well, I could divide the polynomial by um, x minus 4, this linear factor, and the remainder after I do that division will be the value of f of x. Um, so, and we can use that fact and the fact that we can use synthetic division to divide quite easily by a linear factor to figure out the value here. So let's set up the synthetic division. My polynomial is already in the proper order, in order of descending powers, right? So my highest power, 7x to the fifth, comes first, then my next highest power, then my next highest power. So if yours is not in the right order, do that first. And then you simply represent the coefficients of each term. So the coefficient here is 7, 3, 9, 2, 8, and 11. I want to find out what is f of 4. So I'm going to use 4 here. First step, bring down that 7. Okay, then I can begin. 7 times 4 is 28. Add the columns, or the values in the column. 28 plus 3 is 31. 31 times 4 is, what is that, 124? I think, yeah, 30 times 4 is 121, yeah. 9 plus 124 is 133. 133 times 4 is 500 something. I'll just save us some time. 133 times 4, 532. 532 plus 2 is 534. 534 times 4, 2,128. Plus 8 is 2,136. Times 4, 8,512. Plus that 11 is 8,523. And that's my last number. That's my remainder. So that is the value of f of 4. So, it's pretty quick, right? Just a couple minutes. I think a lot faster than doing the plug and chug method. So that's all there is to it. This is a nice advantage that the remainder theorem brings, and that mixed with synthetic division, which is a really slick method of dividing a polynomial by a factor, you can figure out the value of a function, of a polynomial, with synthetic division like that.